Good morning, I am Devasena. In this lecture, we are going to discuss about photodiode. This topic is present in the subject +2 physics. Let us start discussing about photodiodes. Diode. Photodiode is a reverse biased silicon or germanium p-n junction in which reverse current increases when the junction is exposed to light. The reverse current in a photodiode is directly proportional to the intensity of the light falling on the p-n junction of photodiode. The greater will be the reverse current. Symbol of the photodiode is shown below. Here is a representation. The photodiode is having two terminals. They are anode and cathode. And in this photodiode, the visible light is falling towards the photodiode. It is indicated here. Photodiode animation is shown here. In this representation, the light is falling towards the photodiode, the p-n junction. Okay, so if the light is falling towards the p-n junction diode, means current is flowing through the circuit. If the light is taken away from the p-n junction diode, means there is no flow of current. This is represented in this animation. When the light falls on the p-n junction diode, means reverse current increases, and that makes the flow of current. Let us see another animation of photodiode function. Here is a representation. In this representation, the photodiode is connected to a bulb and the other end of the bulb is connected to the battery. Here we will be having a torchlight. The torchlight generates the light, visible light. This visible light is falling over the photodiode. If the light falls over the photodiode, means current is flowing through the circuit that illuminates the bulb. It is indicated here. If there is no light falls on the diode, means there is no flow of current. But if the light is falling on the photodiode, means that will illuminate the bulb that is connected in this circuit. Photodiode representation is shown below. Here is a representation. In this diagram, we are having a P and N region of the photodiode, and at the p-n junction of the photodiode, light falls over the p-n junction. Principle of photodiode. When a rectifier diode is reverse biased, it has very small leakage current. The same is true for a photodiode. The reverse current is produced by thermally generated electron-hole pairs which are swept across the p-n junction by the electric field created by reverse voltage. In a rectifier diode, the reverse current increases with temperature due to an increase in the number of electron-hole pairs. A photodiode differs from an rectifier diode in that when its p-n junction is exposed to light, the reverse current increases with increase in light intensity and vice versa. When light, that is photons, falls on the p-n junction, the energy is imparted by the photons to the atoms in the junction. This will create more free electrons and more holes. These additional free electrons will increase the reverse current. As the intensity of light incident on the p-n junction increases, the reverse current also increases. In other words, as the incident light intensity increases, the resistance of the photodiode decreases. Photodiode package is shown here. Here is a representation of the commercial photodiode. It consists of a p-n junction mounted on insulated substrate and sealed inside a metal case. A glass window is mounted on top of the case to allow light to enter and strike the PN junction. The two leads extending from the case are labeled cathode and anode. The cathode is typically identified by a tab extending from the side of the case. Photodiode representation in another way is shown here. Let's discuss about the operation of the photodiode. The operation of the photodiode is under when no light is incident on the PN junction of the photodiode, the reverse current I suffix R is extremely small. This is called dark current. The resistance of photodiode with no incident light is called dark resistance R suffix R. When the light is incident on the PN junction of the photodiode, there is a transfer of energy from the incident light, that is photons, to the atoms in the junction. These additional free electrons will increase the reverse current. This is indicated in this diagram here. As the intensity of the light increases, the reverse current I suffix R goes on increasing till it becomes maximum. This is called saturation current. So far we have discussed about the theory of the photodiode. Let us discuss about the evaluation. Question number 1. In a photodiode, when there is no incident light, the reverse current is almost negligible and is called dash. The answer is dark current. Question number 2. When the light increases, the reverse current in a photodiode dash. Answer is increases. Question number 3. A photodiode is normally dash. The answer is reverse biased. Question number 4. Photodiode is used in the detection of dash. Answer is both visible and invisible light. Question number 5. In using a photodiode as a photodetector, it is invariably reverse biased because dash. The answer is when photons are incident on the diode, the fractional change in the reverse current is much greater than the fractional change in the forward current. Question number 6. The presence of dark current dash the sensitivity of the photodiode to light. Answer is decreases. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means kindly share this video to your friends. Thank you.